equations always have the same a. The very first number is always negative 16. There's some science, has to do with gravity, velocity, that makes it negative 16. The b is always the velocity. So your problem, if it does not give you an equation, it will give you a velocity. And then it may give you a starting height, which would be your c. So if we are throwing an object in the air, the time that it takes to reach a certain distance is going to be different if I'm on the ground or if I'm standing on the top of the roof. Okay, so that starting height matters. So if our starting height, if it doesn't say anything about a starting height, or if it says it started on the ground, what's the height on the ground? 0. So we would assume it's 0. So every equation, we're going to say h of t equals. That's the height at some time. Equals. It's always negative 16 t squared plus velocity, so v, t, this is my velocity, plus, and I'm going to make these t's kind of like a curve so it doesn't look like a plus sign as much, plus s. I'm going to use s for starting height. So you may not have one if it starts on the ground.
What happens if you don't have one?
It would just, you just wouldn't. If you don't have a starting height, if it's just the ground, you would just not have it at all. So there's 4-ish different questions that I am going to ask you with these word problems. So before we get into those, let's look at what the graph of this would look like. So every graph, my x's or my t, that's my time, and then my y's are my height. So if we're going to start out, let's say we're starting on the ground, and I throw a ball in the air. As time goes on, is my object going up or is it going down? It's going up first, right? It goes up. Is it going to go up forever? What's going to happen? The height is going to decrease. Okay, so it's going to make a parabola shape. It's going to make a quadratic. Okay. So we're going to kind of think about this as we figure out how to answer these questions. So the first question that I could ask you, or one type, find the height at a specific time. So what if I say, what is the height at 2 seconds? Now I'm not going to be giving you the graph, I'm just going to be giving you the equation. So how could you find the height if I give you the time? It's not the starting time. It's what did you say? It's not a starting height. The 2 is my time. So we would put a 2 in for t. So if we're finding the height at a specific time, we would plug the number in for t. So if I give you a time, t is time. Alright. Now, I'm going to skip down to the third bullet. Find the time, so we're actually finding t, it takes to reach the maximum height. What's the maximum height referred to on my graph?
Tallest point.
It is the tallest point. What special word did we give?
No,
It does start with a V.
vertex.
Vertex. So the maximum height is the vertex. If we're finding the time that it takes, so how long it takes, we're going to be finding the x value of the vertex, which had a formula that we did early on, negative b over 2a. So if it says how long or how many seconds does it take to reach the maximum height, you're going to use this formula. Now the actual maximum height. So this question I said, how many seconds does it take? But if I want to know, well, how high is it? Then we're going to find the y value of the vertex. So back up here to the second one. The y value of the vertex. And to do that, we would plug in whatever number we got down there for t. So in order to find, like, if the ball is, when the ball reaches its tip top, in order to find how high that is, we first would have to do the negative b over 2a. And I'm probably going to always ask you those together, so you would do them both anyway. And then the last one, the most complicated, kind of, it's not anything we've not done. Find the time it takes to reach the ground. What is the height at the ground? 0. Those are your x-intercepts. And so it's going to be easiest just to always use the quadratic formula. So if it says something about how long does it take to reach the ground, you're going to do quadratic formula. Now, actually, all of the time, you will either get a negative number as one of your answers or 0 as one of your answers. If that's the case, ignore it. And as we do an example, you'll see that. So as long as you keep up with your notes, you will have this. And this tells you exactly how to solve each type of problem. So let's go into an actual example. A soccer ball is kicked from the ground with a velocity of 90 feet per second. And it gives us the equation. Notice I had the negative 16 plus my velocity was 90. And we started at the ground, so I didn't have a starting height to add on. Okay. So question number 1. What is the height of the ball at 1.2 seconds? How am I going to get this answer?
Negative 16,
Yep. Plug in.
Your 1.2 for t.
Plug in 1.2 for t. So that's what I'm going to do. I'm going to go to this equation right here. And I'm going to plug in a 1.2. And you can, if you'd rather use the store button, you can. So if I do 1.2 store x, and then type in negative 16x squared plus 90x.
So every t that we have for this question is going to be
1.2.
So it's not just one.
It's all of them. Yep.
Okay.
And I get 84.96. And we're talking about the height. My problem said feet, so this is feet. Most of yours will be feet. It might be meters or yards. Just whatever word is used in your problem, that's what you need to use. So at 1.2 seconds, it's almost 85 feet in the air. Question 2 says, how long, so we're talking about a time, number of seconds, does it take to reach the maximum height? So what am I finding on this one? Specifically the x or the y? How long is talking about the time. The time to reach the maximum height is the x value of the vertex. So we have to do the negative b over 2a. Of vertex. So it's negative, and then in parentheses is my b. What is b? Well, we're back on the original problem. This was just at one point. Your 90 is your b. The negatives, it goes in order: a, b, c. So b is 90. 2, and then my a is negative 16. And it's going to give you a fraction, but with these word problems, generally, I prefer you to give decimals because I don't say it's going to take 45 over 16 seconds. If I type in 45 divided by 16, it makes more sense for me to say it's going to take about 2.8 seconds. That makes more sense. So on these problems, give a decimal. So and I'd like you to go to 2 decimal places. So 2.81. seconds. We're talking about how long, so that's a number of time, or number of seconds. It's our time. Are there any questions so far? Okay. Number 3, what is the maximum height? So this is talking about what part of the vertex? The y value. And to find that, we plug in 2.81 for t. So the number we got here, this was the x value of the vertex. We plug that back in to find the y value, which is our height. So I stored. You could just type it in just like this if you wanted. And I get 126.56. We're talking about the height, feet.
Wait, so how did you,
I'd stored the 2.81 for x, and then I typed in this equation from up there. Yes.
okay, let me write all that down, because I'm going to know.
And number 4, how long does it take to reach the ground? What are we doing here? And I'm going to use what? How am I going to find the x-intercepts? Quadratic formula, yes. So I will rewrite it here. Negative b plus or minus the square root b squared minus 4ac all over 2a. That's the quadratic formula. We've spent some time on that. What is my b?
2.81.
No. 90.
Oh, we're using.
We're still.
using alternate answers.
No. Plus or minus the square root of b, which is 90, squared minus 4. What's my a? Negative 16. And c? C is the starting height where it was thrown from. It started from the ground, so it's 0. Your C value would be any number that was added after this. So all over 2, and then my A you said was negative 16. So you type that into the calculator. And remember I said if you get a negative number or 0, we won't include that one. So when I get 0. What that's referring to, we were looking at when it was on the ground. It started on the ground. So that's the 0. That's not the answer I want. I want to know how long it takes to get back to the other side. So I am not going to use 0. I'm going to go back and change it to a minus. So we get 5.63 seconds. All the questions that you would be asked. They won't get harder than this.
I hope not.
All right, let's go on to another example. An apple is launched directly upward at 64 feet per second. When you see feet per second, that is your velocity.
Wow,
From a platform 80 feet high. So that's your start height, your C. The equation,
Negative 16.
it's going to be negative 16 t squared. It's always negative 16 at the beginning. Plus velocity t. So what's my velocity? So 64t plus my starting height, which is 80. So I've got my A, my B, and my C. Those are the three letters that I will be using in those formulas, the A, B, and C. How long does it take to reach the maximum height? What formula do I use for that question?
Negative B over 2A.
The negative B over 2A. So it's negative. My B is 64 over 2, and then my A is negative 16. So we're going to type that in the calculator.
You know,
Negative 64 over 2 times negative 16. That equals 2. So it takes 2 seconds to reach the peak, to reach as high as it's going to go. And at 2 seconds, it starts coming back down. Okay. But we don't know how high that actually is at 2 seconds. So the maximum height, I'm going to plug in a 2 for t. Okay. So you can type it in just like this, or you can store, which I'm going to do. And we get 144 feet. 144. I'm going to go pretty quickly because we're about out of time. So the height at 0.7 seconds, we plug in a 0.7. Now, I stored 0.7. I've already typed in the equation, so I don't have to retype it. And we get 116.96 feet. So it goes almost 117 feet in the air. Okay, and then the last one, the quadratic formula. I'm going to write that out really quick. If you need to wait and get it copied down tomorrow, you can.
quadratic formula go crazy. I feel like I remember it being shorter or something. Is this like a quadratic hybrid or something?
No, this is the same one we used in 5.8.
Negative 16. What is that?
Don't go anywhere. Stay quiet, please. Shh.
Can you have this out for us tomorrow to copy?
So the first time I do it, I get -1. I'm not going to use that one because it's negative. But when I change it to a minus, I get 5. So at 5 seconds, it's back on the ground. So it did not take long at all.